Welcome to Click Academic. This is lesson 3 on the series Mathematical Method. We will be discussing on mean value theorem. So, before a function satisfies the hypothesis of mean value theorem, it must satisfy two conditions. Number 1, the function must be continuous on the open interval a, b. And the function number 2, the function must be differentiable on the open interval a, b. So if the function satisfies these two conditions, then we say there exists a number c between that open interval a, b. So if the function satisfies, there must be that number c between open interval a, b. Then the conclusion of the theorem said f prime of c is equal to f of b minus f of a divided by b minus a. So to find that number that exists between open interval a, b, you have to use the conclusion of the theorem to find that number. For example, we are asked to prove that this function satisfies the hypothesis of mean value theorem. The function given as f of x is equal to x cubed plus 1 on the interval minus 2, 4. So to prove that this function satisfies, we should test f of a and f of b to see that whether the function is continuous on this point or not. So starting with the first one, f of a, and our a is minus 2. So anywhere we have x from the function, we should replace it with minus 2. So x cubed minus 2 cubed plus 1. Minus 2 cubed minus 8 plus 1. Minus 8 plus 1 is equal to minus 7. Then f of b, our b is 4. So anywhere we have x, we should now replace it with 4. X cubed, so it should be 4 cubed plus 1. This is equal to 4 to the power of 3. 4 raised to the power 3. 64 plus 1. 64 plus 1 is equal to 65. So f of a is continuous and f of b is continuous because f of a is not divided by 0 and f of b is not divided by 0. Therefore, the function is continuous on this interval. So let's see whether the function is differentiable or not. First derivative of the function is f prime of x, which is equal to derivative of x to the power of 3 is 3x squared. Power multiplied by the coefficient, then reduce 1 from the power. Then derivative of 1 is 0 because 1 is constant, it has no variable. Therefore, the function is continuous and the function is differentiable. So, since the function is continuous on this interval and the function is differentiable on the open interval minus 2, 4, therefore the function satisfies the hypothesis of mean value theorem. So, since the function satisfies, there must be a number c that exists between open interval minus 2, 4. So, to find that number c, as I said, to find that number, we should use the conclusion of the theorem, and the conclusion of the theorem says that f prime of c is equal to f of b minus f of a divided by b minus a. F prime of c. From the beginning up to this point, we don't have f prime of c, but since we have f prime of x, we can find our f prime of c. So anywhere we have x from f prime of x, anywhere we have x from f prime of x, we should now replace it with c. Therefore, f prime of c now is equal to 3c squared. So we know our f prime of c, and the conclusion of the theorem says that f prime of c is equal to f of b minus f of a divided by b minus a. So this implies f prime of c is 3c squared is equal to f of b, and f of b, that is f of 4. F of 4 is 65 minus f of a. A is minus 2, so f of minus 2 is minus 7 divided by b minus a, and our b is 4 minus a. A is negative 2. Then this implies 3c squared is equal to 65 minus times minus 7 is plus 7 divided by 4. Minus times minus 2 is plus 2. So 3c squared is equal to, we should now simplify this to add this. So 65 plus 7 is equal to 70 2 divided by 4 plus 2, 6. So this implies 3c squared is equal to 72 divided by 6. Since 72 divided by 6, 1, 2, 12. So we are looking for c. We should divide both sides by the coefficient of the unknown, and the coefficient of the unknown is 3. So divide both sides by 3. C squared is equal to 12 divided by 3. So c squared, this implies c squared is equal to 12 divided by 3, 4. We are looking for c, not c squared. So this implies c is equal to plus or minus square root of 4, because if squared across equal sign becomes square root, and if we have square root, it's either plus or minus. So this implies c is equal to plus or minus square root of 4, 2. The number, the value of c now is either plus 2 or minus 2. But the interval given us minus 2, 4. So the number that are between negative 2 and positive 4, because we say that that number c exists between the open interval. So open interval is number that exists between that interval. This implies the number that 2 and 4, they are exclusive. They are not among the numbers. So the number that exists between negative 2 and positive 4 is positive 2, because from negative, after negative 2 we have negative 1, then 0, 1, 2, 3. So the value of c now is 2. That's all.